Hey, Doomslayer. Some good news I could
At
use some
AUC,
today.
we believe in unity through diversity.
At AUC. What's going on, smart people? I just put out a post in my community tab talking about this nuclear physics winter school program I'll be attending in just a couple weeks. And I realized the information I shared is probably not the most helpful if you're not already familiar with nuclear physics and all the jargon and Jesus, the acronyms. So I wanted to put together a quick video going through the program where I kind of speculate what I think the lectures I'll be sitting through are going to entail. Now, this is the second school program I'll be attending outside of graduate school itself. I'm in my fourth year of my PhD. The first school that I attended was called the HUGS program, and it was a nuclear physics summer school in Virginia that I went to last summer. Such a great experience, so I have high hopes for this one. Now let's take a look at the program. So it's called the TMD Winter School, and we'll get into what TMD, acronym number one already. We'll get into what that represents. It's sponsored by the TMD collaboration.
He's not lying.
It's going to be in Santa Fe. It's an in-person. They say they invite, this is what I think is kind of interesting. We invite PhD students and early postdocs doing their research in QCD, which is quantum chromodynamics. That's our theory of the strong force.
Hello,
so you have gravity, electromagnetism, and then the weak and the strong nuclear force. Strong nuclear force tells us all about how quarks and gluons interact with each other and what holds the proton together. So QCD, that's all in QCD. Collider physics, hadron structure, so hadron being one example being the proton, so structure of the proton. Broadly related to the physics of transverse momentum dependent distributions. That's actually what TMD stands for, transverse momentum dependent. To tackle such open problems as 3D hadron structure. So again, a three-dimensional picture of the proton, if that's what helps you think of this thing. Proton spin, which is always a fun topic to talk about. We like to ask, why does the proton have spin 1/2? And the naive, simple answer, you got 2 up quarks, 1 down quark. 1/2 plus 1/2 minus 1/2 gives you 1/2, gives you the spin of the proton.
A plus B.
Very intuitive picture, but it's not right. It's an incorrect picture. Experiments demonstrated that, so that I think in the 80s they used to call it the proton spin crisis.
Yeah.
Where does the proton get its spin from?
What's north?
And since then, people have, I guess, calmed down with age. But
well, I mean, we all have magnetic north. We know what that is, but to one general to the next,
working knowledge
the same team or
theory
different.
is a prerequisite to maximally benefit from the school.
What is up?
I can see that.
Transitory. Well, I use the spin mass direction, but transitory goes to like,
and it probably is because
the position of the red shifting on the periodic table, weights, plates, amounts, pressure.
It was not surface level. Very technical. Page 1 was talking about generators of SU3. So if you don't know QFT, then you definitely probably don't know the group theory. So I think that that's probably a reasonable prerequisite, even though it sounds pretty intimidating. We anticipate the TMD collaboration will be able to support lodging. Okay, yeah, we are traveling there. It's in person. We're all going to be super careful. COVID exists.
$300 computer.
That's not why you clicked on the video. Expected
$300
lectures
we're going to put
and
on.
topics
One thing,
include.
I'm not going to tell you what that thing is.
What are we actually going to be learning? One thing that I do want to point out is that these lectures that you're seeing here, it's not one and done. Some of these will be 3-part lectures, some of them 2-part, but it's not just going to be
a $300 droid, and everybody's going to have them. Well, we have phantom computers and every other
introduction to
things.
QCD,
that's the point.
And it's
not
by
everybody
the same,
can, but everybody can here.
Who gave the lecture on QCD at the HUGS program, and it was very technical, in my opinion. But it let us show, or it showed us what was really out there in QCD, I think. And it's kind of humbling because the theory that came before that, quantum electrodynamics, is like something a child could do compared to QCD. It's very humbling to see like all the time and effort that takes to get into understanding, doing a calculation in quantum electrodynamics, and then going to QCD and realizing those skills only transfer over to an extent because it's just so much more complicated. Maybe it would be useful to go over how all of this stuff fits together schematically first before I just talk about all the lectures. So here I just Googled basically what I knew I was looking for, an ancestry tree of sorts of these objects we encounter in nuclear physics. And at the bottom, you get the really nice, intuitive, physical, observable that we all know and love, something like charge, a density that we know about charge, magnetic moments, momentum, angular momentum. all of that stuff is at the bottom, and as we work our way up the ladder, we get to more
the type of
general
induction
functions
I
that
come
contain
from
that
takes a
information,
quarter and
but we have to work
shrinks
for
it.
it a little bit.
If
So
you do it
we
wrong,
get
the
things
things
that are
weld
more
together.
general and more technical,
You don't
but
want
as
that.
a result, you can answer typically more than
Makes
just
sense.
one question. What is the charge density? Maybe a couple questions. Maybe you don't just want to know about, like, when I'm hitting a quark inside of a proton, what was the fraction of the momentum carried by that quark in the direction of motion by the proton? That's a very specific
So
question.
in a way,
But
there
maybe
was
we'd also
a
like to
quarter
know
that
about
shrunk, a
transverse
flash.
components perpendicular
How much
to the beam
flash?
direction,
Was that
how that stuff
valued
is
in some
distributed.
way?
So as we work our way up this ladder, we get access to those additional
So again,
questions
you don't have
as
the
well.
key
Now,
spin
my world
particle
is all
direction
centered around
going.
the right side of this tree.
You won't know
The
this
densities
is
like charge,
Bernoulli's,
they're Fourier
this
transform
is
loosely
Fourier,
speaking, which is
this
form
is
factors.
Lagrange.
And then if you undo
You
a
do
certain
it because
kind of
on the
integral,
key
you get to what are
page
called
before it,
generalized parton distribution
you kind of talk
functions.
about it in spin mass
And that's what
direction
my life
and
is about 40 to 50%
some
centered around. It's all
Andromeda
about that stuff. And I'm more
Yeah,
so interested in how
introduction.
things like pressure
Get that stuff
is
out of the way, get
distributed
into a
inside of the proton.
either
but you can always ask
here
all of those
again
questions
because
have
it's
to do with
such an
properties of the
advanced
proton
situation
and how you
with
get properties of the
radioactive
proton
things
from the
that
properties of its
really
constituents. So it
need
all
a
contains-
place to go
It all
anyways.
contributes to structural
There's a
information
calculus
of the proton.
gate of limits
nuclear,
that
whatever we're
you
looking at.
really at a
But
minimum
if you go up the left
atom
side of the ladder,
minimum
we go
wave
from charge
function,
to parton
hydrogen.
distribution functions, which are still related to GPDs, which is cool. So I'm also familiar with these. But we start going up this way to the transverse
Mhm.
momentum dependent distributions. You see it depends on K perp, this perpendicular component of the momentum.
Deuterium,
So
plutonium.
it gives you access to that kind of
But
information. But this is
nuclear Mars
also
requires
something
you to
I'm
get
very
plutonium
ignorant
and
about. I do
calcium,
not know much
which
about
is
TMDs.
Penzrow popping
Hence why I'm
through.
going to a TMD school. Very nice.
You,
You go even
you
farther
slide that
up,
in
you
there, and
get, like,
obviously we're
bigger
not going to
functions,
spend 45
generalized
minutes.
transverse momentum dependent distributions.
Is
This is actually
0,
my
1.
advisor, or one of my old advisors. That's actually pretty cool to see. I don't work with these much. However, I've had to use papers whose purpose was to describe these super general
I like
objects.
Walgreens has a value in my
GTMDs,
town of
but if you take the
how
right
much
limits
the
through the
meds
right integrals, you
go,
can
common
get the
cost of a
GPDs from them,
business
'cause it's
model,
more general.
kinetically, the change in
So I
those
was
fields
mostly
are
using
all
these
X
papers as a
calculus.
means of, like,
You would say it's
checking the
formed in
GPDs
beta
that I was
radiation.
calculating. But
I break
anyways,
rules,
so
but
that's kind of
that's
a flow chart. I'll probably show it a bunch
okay
of times
as long as
I'm
I'm not
vlogging about
doing
this
like
TMD school.
Fallopian.
And I'm
like,
sure I'll
that'd be
see it
bad.
just as many times as I'm attending the
YBCO
actual
1 through 3,
lectures because it
and
tends to
not
be a
do the
crowd
ratio
favorite.
right.
But maybe the big point I should be making with the little that I do know about TMDs is they contain information about not just the longitudinal momentum of the target, but the transverse components as well. It's
Pretty
a
good
compromise
particle.
with GPDs because instead of longitudinal, you get and K-perp, you get the impact parameter. So you're trading off momentum information for spatial
use
information in a
Penzrow.
sense. But
Before
going back
the
to
light
programs
comes down
with Intro to
and
QCD, that's going to be tough. I'm
he
so
goes
glad
like
that
this
it's not
to you as a
just one
student.
lecture. It wasn't one lecture for Hugs either, but it
Hugs.
just makes it so much more digestible knowing that this stuff is going to be spaced out a little
Move
bit. We'll
along.
take a look
Well,
at the schedule.
yeah, that's what I'm trying to
a
get
couple
to
minutes.
here.
Intro to TMDs. Since the next one is
A little bit light
experimental,
blinks and
maybe
we
this one
notice
will be more
for
theory
different
driven,
reasons.
like TMDs
He
at the
noticed for his
operator
reason,
level
I
or
noticed for
something. I'm
mine,
not
but
sure.
we both noticed the.
Then we've got something for the lattice people.
Hopefully.
Let's see, do I
Cool.
understand that enough to explain it at all? So my research, whenever I do look at QCD, which is not much, my stuff is more so focused on various simpler models.
You have
But,
to be careful in
if
his
I do
department.
calculations, I'm mostly
In my
concerned with
department, we'll
areas
just set
where
up a
certain
pallet and throw it on
approximations
the
are
Masons
very
game,
appropriate
and
at certain
we will
energies.
work it out.
And if you go to smaller
There's
energies,
only
those
one
approximations
or
are not
two
as valid, but
quantum
we still
dynamic
want to understand the
spots
physics there. So that's where taking a different approach as
Mm-hmm.
opposed to perturbative applications to QCD, one
Simba.
may do a more exact approach.
Just because
on
all day
lattice
this doesn't mean
QCD
one day it'll
using,
be
say,
all
the
yours.
Feynman
You still
path
got
to
SCAR to consider in here.
So there's a couple students at NMSU
And you
where
yourself,
I go
if you
who are
grow
probably
up
gonna
and
be
you
stoked
don't,
for these lectures. And
the
I
faucet
always
doesn't
get
die
something
in
out
the
of them
gorge.
as well
Is
because
that
I
gonna
don't
be-
know much
that
about
gonna be a
lattice
problem
QCD.
later?
Then we have the famous G from G's sum rule talking about how we can add GPDs together to get how and integrate to get how angular momentum is distributed inside of the proton. Spin is a very, very touchy subject in nuclear physics for the proton. Soft collinear effective theory and TMD evolution, and we have this effective theory. Whenever I hear effective field theory,
So you take
my
an
naive
ingot of
mind immediately
lithium,
goes
right?
to you just didn't
And
want
you
to
shoot it
say
with a laser beam in
non-renormalizable,
a
didn't
vacuum
you?
desiccated
But I
chamber.
know that there's so much more to it.
So,
Experiments
then it all
take
goes
place
in the
at certain
tube.
scales and
You
whatnot.
ramp
That
it up.
doesn't need to
That's
be
the spin. Nah.
valid at all at beyond what it's being used for.
Starting the ingot at the gaseous phase.
To appreciate effective field theories more, but I still think they're funny. Matthias Burkhardt, that's my other research advisor, who's going to be giving a talk on
I know that number.
orbital angular momentum.
I'm sure I said that number, and the rest of the number fell in place.
Gave the interpretation of what GPDs represent, how it's describing how the quark that you're hitting is distributed in like transverse position space, so like the impact parameter, so to speak, as well as the longitudinal distribution of the momentum. So in a sense, it's a three-dimensional picture of the proton with an asterisk on there, because one of those pieces of information isn't spatial. It's momentum.
I learned well, hold on, Oppenheimer.
Even though we could extract physical things from GPDs, people
didn't put a safety thing around it.
Then we've got TMD,
what happens if I do touch it?
X is not a position, by the way. It's actually a momentum fraction, so it's related to the fraction of the quark's momentum that you're hitting to the total proton momentum. There's additional, we can make it more complicated if we want to, but it's related to momentum fraction.
It's like my friends got it. I was like,
TMD is in dense matter. Now we're getting into things that I know so little about, I can't even pretend to explain it. But the fact that this stuff is on primarily TMD physics, which I know so little about, is really nice and good timing, because at the Hugs program, I went into it saying, I want to be exposed to what other people are doing in nuclear physics, which was the case at times, but there were also a lot of lectures that were pretty closely related to my own research. Like the experimental lectures were on deeply virtual Compton scattering, which is the avenue of accessing GPD information, so that's right up my alley. Whereas here, if they're talking about experiments for TMDs,
you have an electron,
on deep
depends
and elastic
on where
scattering
spin starts.
probably, which I also know less about.
When you get into
Hugs,
those should be the simplest of those types of diagrams, probably, or even the way you laid them out, the E0, E to E1.
And about another year.
But I would have no clue. I mean, I have some basic Feynman diagrams should get you there, but the logic behind the code on prime,
I can actually handle learning what other people are doing. So I'm really excited for this. Let me know in the comments section.
I know calcium fluvium. Get to make a laser beam, or where the hell that is on the planet at the moment.
In my application to this program, I asked if it would be okay if I were to record the experience.
Easy to check, easy to look up, easy to be cheaper.
And they responded kind of by hiring me to record the lectures themselves as well. So I will have the lectures. I don't know what they will plan to do with them, if there will be a repository that's for the students,
use
or if
it
it's
like,
for the
well,
general
you want
public.
to study that. I mean, you could.
But as I find out
but it's like
information, I'll
more
be sure to
set
let
for
everyone
schools.
know.
This
so,
is
thank you for watching. I'm real excited for this
QCD
winter
or
program.
QED.
Excited to make
This
some
is your
videos on it
safety.
again, because I've been slacking.
Safety, quality,
let me know in the comment
quantity.
section if you enjoyed the video.
36 inches, X pounds.
When you crave the uncomfortable, try spicy Pringles scorching.